Everybody. Let's get started with our first real unit of Earth science, latitude and longitude. These are probably terms you've heard before, but we're going to look at them from a little bit different perspective than you've probably heard them in the past. Let's start with giving directions. We live in the greater Los Angeles area, but let's say somebody from Nepal, which is in the Himalayas, wanted to travel here. Without showing them on a globe or a map, how would they get to Los Angeles? How would you tell them to get here? And due to cultural and language differences, would they be able to even understand your directions? How can you fix the problem of making sure everyone can travel without having direction problems, language problems? Is there even a way to make that happen? Well, we have the cardinal directions, north, south, east, and west, and those are pretty universal across the entire world now. But is this enough? Could you just say, go north, go south, go east or west to make someone from the other end of the world know how to get to Los Angeles? This is why scientists and adventurers and cartographers invented latitude and longitude. They wanted a better way to map the world. So let's start with lines of latitude. These are imaginary parallel lines that run east to west or west to east. They run horizontal, the same as the floor essentially. And they divide the Earth into northern and southern parts. There's one called the equator, that's the central line, and it divides the Earth into equal north and south parts. We call this 0 degrees. So whenever you've heard someone give directions and they say degrees or something like that, that's when they're talking about lines of latitude and longitude. Now, these measure the distance north and south of the equator. So if I say 40 degrees north, that's how far I am to the north of the equator line. So these lines are parallel. They never cross each other. If you notice, there's one right here and the other one is right here. These never cross each other. They always stay the same distance apart. It's exactly 10 degrees apart between each line of latitude. So the equator is going to be the longest line or the biggest line because it crosses the Earth at its widest point. Everywhere else, the Earth is a little bit smaller than at the equator, so all those other lines are going to be shorter than the equator. The poles, what we call 90 degrees, are the shortest lines of all. Now longitude, these are our long lines. They go north and south. They run in imaginary semicircles. And what they do is they split the Earth into east and west halves. So the prime meridian is the central line, and this one is similar to the equator for the lines of latitude. Because we call this one the prime meridian, sometimes you might hear people call the longitude lines as meridians. So you could say, this meridian or that meridian, but they just mean lines of longitude. Now, these measure how far east or west you are from the prime meridian. Now, this line is, it passes through Greenwich, England, which is pretty close to London. And it's where the Royal Naval Observatory is located because at one time, England was the world's superpower. They used to say that the sun never set on the British Empire, that they had so many colonies all over the world and they needed to know how to travel there. So they had a lot of scientific and exploration groups that were very invested in mapping the world. So they kind of set the standard for how we would measure and map the world. These meridians are measured from 0 degrees at the prime meridian in Greenwich to 180 degrees on the opposite side of the world from England. These lines get closer and closer together when you get closer to the poles, and they're further apart the closer you get to the equator. This is because they cross the equator at right angles, so they always want to be at a right angle, meaning it makes like a perfect L shape. I know that's not perfect, but a 90-degree angle to these lines of latitude. So they kind of have to bend a little bit with the curvature of the Earth. So these ones are lines of longitude. They go north to south, and lines of latitude run east to west. These divide the Earth into eastern and western halves, and this divides the Earth into north and south halves. So you can kind of see how it divides the world in these images here. So on your notes, I want you to pause the video and take a moment to answer these 3 questions. Why do we say that the pole latitude lines are 90 degrees or the longitude lines go up to 180 degrees? Where did we get these numbers from? The second one, what does this mean for the quadrants of the Earth? Northeast, southeast, northwest, and southwest. How do these degrees affect the way we divide the Earth into quadrants? And what does it mean for the Earth as a whole? How many degrees does the whole Earth have if we're going around in latitude or longitude? All right, so how do we measure these lines? In the questions before, what I was trying to get you guys to think about is the fact that circles are 360 degrees. So if you start at 0 and work your way around, eventually you will get 360 degrees. Now, any sphere is made up of the same number of degrees. And this is just a unit of measurement for how we break down the angle in circles. So the prime meridian and the equator are both the starting point. That's why we call them both 0 degrees. And we move away from them and go higher in the number of degrees. So if we have a line of longitude, like the prime meridian, and I want to move from Greenwich, England, where the prime meridian is, to the opposite side of the world, I've traveled 180 degrees. But now if I am at the equator, and my equator is 0 degrees, if I travel this distance, I've only traveled 90 degrees. That's why the north-south poles are 90 degrees. And that's why our prime meridian is 0 and the opposite of it is 180 degrees. Now what this means is every quadrant is going to be 90 degrees. So northeast covers 90 degrees of latitude and longitude. Northwest covers 90, southwest, and southeast. Now, because we can measure the Earth in degrees, we can actually calculate how far each degree is. Kind of cool. But first, let's get into this a little bit. There's 4 other famous latitude lines. You've probably heard of them before. There's the Tropic of Cancer, which is north of the equator. There's the Tropic of Capricorn. And then you have the Antarctic and Arctic circles. So these are just the famous dividing points. They're latitude lines that have become so famous that we've given them names. So now how do we take this knowledge of the Earth is broken down into 360 degrees and turn it into something that we can measure distance in? Well, we've calculated the circumference of the Earth, or how far you would travel if you walked all around the surface of the Earth, and that was 40,000 kilometers. When you do the math, that would make each degree of latitude 111 kilometers. Now, we use kilometers in science, not miles, but if you were curious, that's about 68.9 miles. Now, we can even break this down further because that's a pretty big distance. That can cover a lot of area. So we can break down a degree into a minute. And a minute is about 1.8 kilometers, or a little less than a mile. Now, Each minute can also be broken down into what we call seconds. So you have degrees, which are the largest, and they get broken down into minutes, and minutes get broken down into seconds. And these are just ways that we can measure distance and give very, very precise points. So each second is about 30 meters. So that's about 30 yards. Now, remember the problem at the beginning that we had somebody in Nepal who wanted to know where Los Angeles was. So how can we give him really accurate directions to get here? So you could tell him that Los Angeles is along the 34-degree latitude. But is that enough? If you just say 34 degrees latitude, that could be anywhere along that line, or it could be anywhere along that line. Remember, we have a north and a south 32 or 34. So you have to say whether the degree that you're mentioning is north or south of the equator. So LA is going to be 34 north. It's north of the equator. But there's still more. If I say 34 north, well, that can also mean anywhere along that line. If you just say go to 34 degrees north, he could end up in Florida or in the middle of the ocean. So we have to tell him a line of latitude as well. So just like with latitude, lines of longitude need to be used in order to give them precise directions. Now, because these ones change their shape, they're not parallel to each other, they have no set distance. So we can't really do the nice, neat numbers with minutes and seconds like we do for lines of latitude. So to give accurate directions, we have to add both. So now we know that LA is at 34 degrees north of the equator, and it is at 118 degrees west of the prime meridian, which is somewhere way over there. So it's 34 degrees north, 118 degrees west. You may have seen this before or heard its term. It's called a coordinate. So if I want to give you my coordinates, which is what you use for GPS, I would be talking about degrees of latitude and degrees of longitude. Now, could we give even better directions to LA? And if so, how? Well, we could add our seconds and our minutes and things like that, and that would make it even more precise. So you just have to keep adding more little details to get actual precision of where you want to be. So let's talk about a problem here. You're in an airplane, and the airplane flies from 30 degrees north to 42 degrees north. How far have you flown in kilometers? So these problems, the way you're going to do them in the future, first you have to figure out how many degrees have you traveled. So we started at 30 and ended at 42. So I have to subtract those to figure out how far, how many degrees I actually traveled. And that's going to be 12 degrees that I traveled. And remember that every degree is 111 kilometers. So now I multiply 12 degrees by 111 kilometers. And you get 1,332 kilometers. You can definitely use your calculator for this. I won't make you do that in your head. And if you're curious, that's about 827 miles. So that's how we can use lines of latitude to actually figure out how far we've traveled. So you'll want to pause the video again and answer this question before you move on. How might people have located specific landmarks or places without using these latitude and longitude lines? How did we used to travel before we had this system in place? When you're done answering the question, you can move on to the next slide. Now, we'll talk about the answer to that one in class tomorrow. But for now, let's move on to our second way that we divide the world and kind of map the world. We like to use time zones to figure out what time is it where I'm living. So the Earth is divided into 24 different time zones, one for every 15 degrees of longitude. So why 24? Well, because we have 24 hours in a day. So it's every time zone is 1 hour. We calculate these times based on the coordinated universal time. And where is that set from? Greenwich, where the prime meridian is, where we kind of have our 0, is where we are going to start our time. You may have heard this called Zulu time if you have anyone in your family who's in the military or who's a pilot. So America has 6 time zones. It has the Hawaii time zone, the Alaskan, the Pacific, which is the one that we live in, Mountain, Central, and Eastern. You will have to know those for the test. How many time zones do we have and what are they? So as I said, we are in the Pacific Standard Time. Now, if we're using our Universal Coordinated Time, or Greenwich Mean Time as it used to be called, we would write it as GMT -8 or -0800. And that's saying how many hours are we away from the prime meridian. We would take the prime meridian time and subtract 8 from it, 8 hours. Now, not the prime meridian, because the prime meridian is over here, but there's a line called the International Date Line. It's an imaginary line that separates one day from another, and it's located at the 180 degrees, so it's on the opposite side of the world from the prime meridian. So if you're looking at it, it starts here, and then it kind of takes this really crazy trip around the Pacific Ocean. Why is it not a straight line? Why do we have such a funky shape to this time? Well, the easy answer is because it's more convenient that way, because it's political. If we have different time zones in the US, you can end up with some people living in one time zone and working in another, and all their driving is 20 minutes. Can you imagine how confusing that would be? So what some regions have done is they make their time zone line kind of curvy to make it fit the area better, so that some people don't really have to change their clocks when they go into work every day, or so a town isn't split right down the middle, one time zone and another. Some areas do things like daylight savings. There's even some regions of the world, like in India, that do half-hour time zones. So people tend to take their own needs out of this. They'll change things up to make it work for them. So let's go over a summary now. The Earth is divided into horizontal lines of latitude that run parallel to the equator and to each other. This divides it into north and south. The Earth is also divided into semicircles of longitude. They meet at the north and south poles. The main longitudinal line is the prime meridian. This divides the Earth into west and east, not south. We measure these lines in units called degrees, and we say they can go from 0 degrees to 180 or even 360 degrees. These lines are used to give accurate locations or coordinates for specific places on Earth. We also talked about time zones. The Earth is divided into 24 time zones, one for every hour, and each is 15 degrees wide. All of this time is based off of the Coordinated Universal Time, UTC, at the prime meridian. The line that separates days is on the opposite side of the world from the prime meridian, and it's called the International Date Line. And the United States has 6 time zones. If there's something that you didn't understand about this video, or if you have questions, write them down in your notes and make sure to ask them to me at the beginning of next class, okay? I hope you guys enjoyed the video and you learned a little bit, and I will see you soon.